phone calls. How sad. Monday back from break and they don't miss me.
I was gonna go home. I need a food truck.
Oh, thanks. No, I don't think so. I called like my e-learners, like Leland. That's why it's so quiet, maybe.
He's not in class?
No, I know. He's always like one of the first ones. All right, welcome back. I hope you guys had a good week off. Maybe, maybe not.
I was sick.
I've learned I can't grade your food projects while I'm hungry, so I did ignore them for a bit. They've actually, the few that I have perused at have looked good so far. Just a couple of announcements in general. Obviously, you guys are already in AP, but if you were interested about the other AP courses that we have, because we have 17 at this school,
Don't do it.
they're all in AP right now. Then you can attend the meeting tomorrow. The other thing is, what? Oh, you're so much pain. All right, the other thing is I put up this morning is the esports team that we're starting this year at Sierra High School for the first time. League of Legends, Rocket League, Madden, Smash Bros, and Smite. No experience necessary. So if you do any of those, Keenan, then I definitely want you guys to let me know. And Mr. Disney is also going to be coaching it. So I know, right? Especially because I wasn't allowed games growing up. There's Leland. All right. Good morning. All right, as far as your schedule goes, I've got your reading guide up. We're going to crash through some notes. This looks worse than it is. If you look in your packet, you can see that they're actually pretty short. I feel like we'll get through all of them very quickly today. 3 sections, but only 2 DOLs. Only 2. Wednesday, we're going to go through, I'm going to have you guys set up your salinization lab. So those of you that are e-learners, I have your kits ready to go. For the most part, I'm still counting out little seed packets, but I will deliver those after school today. If you want me to text you before I walk up to your door or something and ding dong ditch without the ding dong part, let me know and I'll send you a text as I'm on my way.
Oh, you could have delivered my stuff to me.
I could have. Just so you guys know, if you are not aware, oh, I forgot about this. This unit is so big, there's 2 progress checks for it. Yep, so we'll do 5, oh, I forgot to take that out, 5.8 notes and progress check. And then Friday, there is no class. Friday, you guys have the mock SAT. I got nothing. I don't even know what the freshmen do at this point. They haven't sent out anything other than Ashley. All right, so that's kind of your review for this week. Do you guys have any questions before we get going? I have no idea, to be honest with you.
You let me know, and I'll see if I show up.
Hi? Which one is it today? Probably a little more capitalist. All right. All right. So like I said, we're going to crash through 3 sections of your packet. If we finish early, you guys will have some work time. So keep that in mind. As Jesus asked earlier, why don't we just watch something on TV? I would like to, actually. I have a couple I'd like to watch, 2 particular. Was it Meat Hooked and I forget the other one. It's on Hulu, though. But we'll see if we can get through stuff fast enough maybe next week. All right. section 5. You guys all have your notes out, correct? I hear a sad yeah.
I don't know. I don't know how to see. The water main break has a part.
Oh, means the pipe that delivers water to your house broke.
Nice.
All right, so this first section is a little, yeah, it's very itty bitty. 11 slides, including the title, about the impacts of agriculture and how we actually do some of it. So the first part is plowing and tilling when it comes to agricultural farms. It turns the soil upside down, pushes down crop residue, kills weeds, insects. It also pushes down organic matter to try and get nutrients back into the soil a little bit. This increases erosion. So remember, erosion is the movement of sediment, and because it loosens up the soil, so it makes it easier to move. It exposes organic matter to oxygen, which in that decomposition process increases CO2 in the atmosphere. So it oxidizes, just like rust. And then lastly, leads to soil degradation along with the irrigation and overproduction. So it degrades the quality of the soil. It is nice. Oh my god. Let me. Jesus says 13. I'm still. Section 5. Yep, there you go. All right, am I good to go? No? The next slide's just a video, so that part will be slightly easier. No, it is not the guy who talks fast. I don't think I have one of his videos for a while. Yeah. Oh no, you can't?
After a while ago.
Oh, that's funny.
Then it's on that, if it's on the day of it, no, I can't because it's already in my head. But after that, I'm like, I don't know how to do this. Are we kidding me?
If there's something important, I'll say, write this down. All right. Let's see. Are you gonna? Come on. I'm impatient.
Miss P, I don't think your audio is on.
No, I'm trying. It's not letting me. Hold on. Come on. Maybe if I go off screen. Come on. You go. I wonder if it's because this isn't full screen. I think that's why. There it is. This is the plow and till. All right, now e-learners should have sound. I couldn't get to that little.
During our Farm Basics time today, we're going to talk about old school farming versus new age farming. Well, that's kind of how we like to talk about it quite often, where it's the moldboard plow versus no-till.
Honestly, Brian, it makes me a little uncomfortable even to have the conversation now. I'm not fully employing either of those systems. I like something in between, and I would venture to guess most farmers are somewhere in between. But there are kind of a couple of extremes here where I'm never going to do tillage. I think tillage is always bad, and this is how I'm going to do things, versus, hey, I'm going to do heavy tillage out on the farm. Now, I get concerned about the erosion, Brian. That's why I'm not so big for the heavy tillage.
All right, so we want to talk today just a little bit about what is moldboard plowing and what is no-till. So if you are a non-farmer, you can understand some of the things that we have to work through on the farm. So Darren just brought up soil erosion. If you go back to the 1930s, it was called the Dust Bowl, the Dirty 30s, because the only way to control weeds, insects, and diseases back then, and also to get a good seed bed, was to do massive amounts of tillage. Basically, make the ground black. Well, when you do that, now you're subject to erosion from wind and from rainfall, and that can obviously be problematic. But the thing that I like about moldboard plowing, and what this basically is we're going to take the soil and we're going to really turn it over maybe 6, 8, 10, 12 inches deep. The thing that I like about it is now it is kind of stirring everything around. So if I laid some fertility on top, I laid some manure on top, now I can really get that down into the soil. So I'm excited about that. Also, when you moldboard plow, you're going to warm the soil up a little bit. You're going to speed the mineralization process, so some of your organic matter releases more nutrients for you. In effect, you get some free fertilizer, in the short term anyway. So there are many advantages to moldboard plowing.
Well, on the other side, Brian, let's look at some of the disadvantages. And we mentioned erosion. That's one that if you told me, hey, look, I guarantee you 0 erosion off your field, I would be more interested in doing it. But here's some other things that are potentially negative. One is my organic matter levels in my soil are going to go down because I'm going to burn up that residue that much faster. Now, if you say I'm only looking at a 1-year gain, then I'd say, oh, well, then moldboard plowing is great. But if I'm going to farm this ground for the next 20 years, I don't want to do a whole bunch of moldboard plowing. At least I don't want to be doing it every year. So it's something that I'd say, well, maybe I'd consider it once every 5 years or once every 10 years. Well, the other thing is microbes. When we look at the microbes and we look at earthworms, they need a home that's kind of stable. And when you're going to completely disturb that, you could negatively influence what's going on with your microbial life and ultimately your soil health.
Well, you could, but I don't know that in 1 year you're going to change all that much. Now let's talk about no-till. The big advantage is you don't have all this machinery running across the field. You don't have to take the time and the effort to get any work.
And expense.
Right, to get this work done. So that's great. The other thing is, with the soil being left undisturbed, it gives you a better chance to build soil organic matter, and hopefully, to Darren's point, we can improve overall soil health because there are more beneficial microbes and earthworms and everything else that has a nice home.
Absolutely, and potentially we could avoid the compaction, which is another issue by doing heavy tillage.
Yep, but the downside to no-till that I look at is it's very common for people to get their nutrients stratified, so they apply fertilizer or manure on top of the ground and it doesn't go anywhere. So now all of a sudden all their fertility is on top and the roots are down below and they can't get it. Also, when you take a look at this compaction thing that you mentioned, well, if there was compaction going into your no-till and you don't do any tillage, how are you going to bust that compaction up? It usually just stays there and remains a problem for quite a long time unless you make some major changes, throw cover crops in, that kind of thing. The last thing I was going to throw in was your soil is colder. So it's very common to see much slower emergence in those no-till soils. And it's also common to see guys, instead of planting 100-day corn, they plant 95-day corn just to compensate for that.
You can see there's some big advantages and disadvantages of both extremes here that we're talking about, which is why many farmers fall somewhere in between, not doing complete no-till and not doing super deep heavy tillage either. Fortunately, in both of those systems, you can still control our weed of the week. We'll show you how to do that coming up later in the show.
We don't even have a word now. Oh my gosh, you're so whiny. All right. So what were some of the things I mentioned in there? Because there's a couple more other than even the stuff that we just talked about up here. Good and downsides. Good and bad sides.
Compact soil stays frozen longer.
Okay, so got a couple answers about temperature. The compact soil, one, it's hard to get nutrients through, but it stays frozen longer as opposed to looser soil. What was their recommendation at the end by going through all of this?
Yeah, you got to be somewhere in the middle.
Got to be somewhere in the middle. Good. All right, and that's kind of how they looked at it. What do you mean? Where do you write increase? The first box. All right. Next one, slash and burn. Maybe. There it goes. Oh. I'm gonna minimize it because my start bar is covering up. Sorry. Hi. All right. So slash and burn is another way of farming. This is actually what Florida's going through right now. There's a whole bunch of people protesting down in Florida because of the slash and burn of sugarcane and the particulates it puts into the air, and it's extremely unhealthy. And everybody like near a field is just like coughing and has all their windows shut, trying to make sure their air quality indoors stays good. Even with the mask, they're still struggling. This is where they cut down trees or vegetation and then burn it, resulting in ash, which is those particulates in the air. It does provide, just like forest fires, it does provide a lot of nutrients for the soil. However, you are losing a lot to the ash that goes and disperses throughout the area. It is not a sustainable practice. And we talk about being able to do this constantly over and over again and avoiding things like another dirty 30 or dust bowl, then this is not one of the methods you would work on. Poor, nutrient poor soil and warm climate. What biome do you guys think that is?
A desert eventually.
Yeah. Here we go. All right, will it go back? It will go back. Yeah. Can I go to the next? Everyone good? Shut up. We'll get there in a second. All right. Oh, God, it's not showing again. Stupid start bar. All right, so when you do the slash and burning, it releases carbon monoxide and carbon dioxide. Like they said earlier, it leads to more erosion, loss of topsoil that hold on to those roots. And then it's a positive feedback cycle. What's a positive feedback cycle? Going back to like the beginning of the year.
Just to circulate.
Well, cycle? No, it's not procreation. Oh my gosh. I mean, it could be. All right. Remember, we have positive, negative feedback cycles. The negative is where everything in that ecosystem kind of stays in check. When we have a positive feedback cycle, that's when it's starting to spiral out of control. So when you're talking about a positive feedback system within agriculture, what might it look like? Just think out loud.
Fires. Lower crop yield.
Lower crop yields. And then you, after that yield, you slash and burn, and then you have even lower crop yields. And it just continues until it's absolutely worthless. And that term is desertification or desertification.
I feel like they didn't know how to name it because feedback was going to be negative if it's going to turn out bad, positive if it stays in check.
You would, well, yeah, I could make a case for it either way. I honestly could.
I can agree with
Yeah, right. Irrigation can lead to salinization. This is what the lab that we're going to do on Wednesday is all about. And that leads to desertification. So land rendered completely unproductive.
You're going to say completely useless. I would have said, okay, what does that mean?
I'm going to now define useless that way. Isaiah Madrid. Get your name in the dictionary.
Sure, I'm in the dictionary.
Are you?
Yeah.
As in Noel?
No.
Oh.
I think there's a few words.
Yeah. Yeah, I do. Sir, I'm gonna watch TV. All right, everyone good? All right, I think I can go back to presentation mode. So here's some desertification. We have our normal desert areas like the Sahara, you have the deserts in the Southwest. Areas vulnerable to desertification that necessarily shouldn't always be a desert is all in yellow. So it's all those edges and even places like if you look at Brazil or even the western half of the United States, that's all places that potentially would not be able to grow anymore. All right. All right. The Sahara is expanding 30 miles a year, so it is getting bigger and bigger and bigger, which is kind of cool.
Cool.
I think so.
Desert?
Yeah.
So that it's getting bigger?
Mm-hmm.
Which means there's more sand?
Mm-hmm. What do you mean? It's
Where
broken
is the
down.
sand growing from?
Growing?
Well, if you get bigger,
It comes from bedrock. I can tell you didn't pay attention in your Earth class.
Are you sure the Sahara is importing it?
They're not importing it. Side note, while I get this to load, Bill Gates, who lives in Washington State, he imports the sand for his beach. So Mr. Let's make the environment healthy and we can't do this and that pays to fly sand from Florida to his beach. You're welcome. Freaking hypocrites. All right.
That sounds pointless.
It does. I mean, not that sand in the Puget Sound is any good. It's all gravel pretty much. But yeah, that's your guy that's telling you that you need to save the environment. All right. So here's a quick video. There's an article that goes along with it, but we'll just watch the video for now on Amazon Rangers and how they battle farmers burning.
In the Brazilian state of Mato Grosso, the world's priorities are etched onto the borders of the Amazon with geometric precision. This line divides the world's most productive soy fields from the world's greatest forest carbon sinks. One side fills the world's bellies, the other regulates the world's climate. For most of the past half-century, humanity has tended to put our stomachs first. Farmers have rapidly expanded their land by using fire, bulldozers, sawmills, and logging teams. So much so that with the next harvest, Brazil expects to overtake the US as the world's biggest soy-producing nation. Evandro Carlos Selva is part of a team of high-tech rangers who use satellite monitoring to track down and where possible prevent forest clearance. It appears to be working, thanks largely to their efforts. Deforestation in the Brazilian Amazon has slowed by more than 75% since 2004. Each season, farmers still start fires and use chains to clear the land, but Environment Ministry rangers, like Selva, can move rapidly to the affected areas, confiscate equipment, levy fines, and cut access to bank loans and business markets.
Você tem mais ferramentas para trabalhar, Então, isso ajuda muito a fiscalização. Você tem uma capacidade muito boa de deslocamento rápido, com aeronave, com veículos de boa qualidade, né? Então, é mais fácil você combater.
The government says operations like this have helped to reduce carbon emissions from deforestation by 56%. They're the result of an innovative collaboration between the Space Agency and the Environment Ministry.
And we can see that it was green here, forest. And now what we have is this pink area means that the area was deforested. And all the law enforcement officers, they go to the field with this information in hands. The key factor that is giving us this very successful strategy is combining the monitoring system with the control system. I mean, monitoring and control are working very close and together to tackle deforestation in Brazil.
So having an eye in the sky and feet on the ground.
Yes, always.
It can take just 2 days for the teams to respond. They have to be armed. This is a wild frontier, and money and land are at stake. All too often, they are still too late, as in this case. Further on, the rangers find the tool that probably caused the devastation.
Correntão, que é acoplado em dois tratores, ele vai puxando para revolver as raízes da floresta, para ficar mais fácil limpar, para depois mecanizar, passar a plantadeira, o trator, a colheitadeira, né, que vai colher.
The battle continues. Next year, 2 new satellites with higher definition and radar monitoring will sharpen the remote eyes of the rangers. But with soy prices rising to record highs, it's going to be even harder in the future to hold the line between the food and the forest.
So that kind of gives you a visualization. Some of that does happen here in the U.S. as well, just not to that extent, but it does happen with farming. So they were kind of getting rid of some of that rainforest aspect in order to use up, to extend their farms and fields. That's what they were saying when the stomach wins out, or in some cases money as well. That type of farming is extremely degrading to the environment. So, all right, fertilizers. Kind of like Leland was mentioning in the chat, large amounts required to replace lost organic matter and nutrients. NPK, what does that stand for? Anyone know?
NPK. Not a lot of things.
Nobody knows their periodic table?
Nitrogen, phosphorus, and potassium.
Potassium, yep, nitrogen, phosphorus, potassium. So when you go to Lowe's or Home Depot or Ace or whatever it may be, and you see these 3 dash numbers, that's right, I have that t-shirt. Nitrogen, phosphorus, and potassium, those numbers are always in order, and based on the type of soil that the plants that you're growing may need, you'll see different amounts. The numbers because that's the amount that you're getting. And so plants like certain ratios, or ones that might like more acidic soil or more basic soil, you might need to have like more potassium in it. So so things like that. So depending on what the needs are of the plants you're growing, that's what fertilizers are for. And then we've talked about this a little bit already. Organic is just mostly decomposed manure. It's nothing fancy, made in a lab. Maybe. There it goes. When we talk about synthetic or inorganic fertilizers, that is the combustion of natural gas fixes and captures atmospheric oxygen. So if you remember from your nitrogen cycle, you have like nitrogen fixing bacteria. So you actually get kind of like something to trigger that reaction in the soil. So that's why it's synthetic or inorganic. It's not just natural dead organic matter. Some benefits or advantages is that it's easily applied and it absorbs right into the soil and into the plants. The content can be adjusted, like we were just talking about, like the different amounts of nitrogen versus phosphorus for different crops or soils. So if I have really good amounts of phosphorus and potassium in my soil, but like no nitrogen, I can go and get a high nitrogen fertilizer, add it, and boom, I've got my good soil. Without synthetic fertilizers, we actually would not be able to feed the world. So if it wasn't for that, we would have been screwed already.
Fertilizer. So you don't produce more something like that. Only feed those who can feed by getting rid of the fertilizer.
Could think about it that way, yeah.
That way, anyone can question you, but you didn't do anything wrong.
Mm-hmm. All right, so this graph down here, it's cut off a little bit, and I'm sorry, but we have nitrogen fertilizer used in the U.S. This is the total amount used, and then for tons, and then this amount here is used to grow corn. Why might that line be really important? It is a commonly grown crop, but why is it commonly grown?
Because it's genetically modified.
It's like I have feedback. It is genetically modified, but remember, corn, one of the biggest things that it goes to is to feed livestock. So corn feed, for your chickens, for your cows, all of that. So when we talk about needing fertilizer and needing it to even almost 50% of our fertilizer used goes towards corn, without that synthetic fertilizer, we wouldn't have meat. So think about that. Knowledge bomb, I like it. Synthetic fertilizer drawbacks or disadvantages. Fossil fuel energy. All right, it does take a lot of fossil fuel energy. We're gonna crush fossil fuels like it's a dead horse in the next unit. Carried by runoff to groundwater and waterways. So we've talked about eutrophication before and how it can do the algae blooms and turn water green, things like that. It can get into the waterways. No organic matter is being added, which helps raise the CEC levels. If you remember talking about that with soils, that's that positive, negative. It can hold on to nutrients. And then the water retention abilities. Maybe a quarter.
No, we don't need it that badly, do we?
Yeah. Me too. Nobody told me my fly was unzipped last period. I was like so embarrassed. I don't know how long I was walking around with my pants unzipped. It's probably because I'm too big. All right, everyone good on this? All right, so we're gonna move. Like I said, we're gonna crush through a couple of notepads. Irrigation. If you've ever fallen into one of these, it hurts, by the way, just so you know. They're really hard to see.
About rice fields. Doesn't have that much.
You fallen into them? Me too. Well, playing in them and running and then not realizing one's there and face planting.
Oh, well, we realized that they were there.
How do you fall in those?
I was out doing field work and I wasn't paying attention to where I was going. Thank God it wasn't a concrete one, but it was about 7 feet deep. Climbed out. Yeah.
How do you climb out of those? It looks smooth walled.
Like this, like I'm dog paddling, but in dirt.
Oh, so you were able to come out of something like 4 feet taller than you?
Yeah. All right. So we're going to talk about irrigation as far as farms go. And this first slide is really just about the amount of water we have on our planet. So the left picture, sorry if it's blurry, but we have briny, saline, and brackish water. All of those are water with salt in it, just different levels. And it tells you in there that the briny water is the 50 plus parts per thousand. Saline is 30 to 50, which is often like your bays and stuff where you get fresh and salt water coming in. And then brackish, 5 to 30. So where your fresh water tends to meet the salt water. And then down here, this almost zero, and down here is fresh water. Within this little amount of fresh water, you have 68% of it going towards agriculture. So almost 70% of this little bit down here of water on the planet is going straight to making crops and food. Just under 20% for domestic and industrial, 10% for power, and 3% evaporation, which is part of our water cycle. That's normal, it happens. So not a whole lot. Oops. When we, did I not put, oh, I'll go back for that. Largest human use is agriculture. Oh, I'm not on here. I thought I was scrolling, sorry. All right, so we'll get into the different types in a little bit, but 16% of our agricultural land is irrigated, and it produces 40% of our world's food. So we're trying to increase productivity by watering, is really all it's saying. We're not going to wait for the natural rains to come. All right, waterlogging is when roots cannot get enough oxygen. So this can also raise your water table a little bit. If you're in a place that is constantly waterlogged, which is not necessarily an issue on eastern Colorado, but western it definitely is. And like where I just moved to from Maryland, I could dig into the roots of the soil and see orange dirt around all the roots, like bright orange Broncos colored dirt is what color that soil was, because it's trying to exchange and it's getting waterlogged and it's struggling and it's oxidizing, almost like creating rust. So that's what happens when things get waterlogged, and then eventually if they can't handle it, they die. Right, the entire state of Louisiana. There you go. That's.
Remember that field trip we went on?
Which one?
The where we found Dead Squirrel, the water place.
Oh, yeah. That was comforting.
It was crazy. I thought the question that I should have asked while I was there last time is what do they do when like somebody throws up?
It gets filtered out, the chunks.
Yeah, but like. You didn't really somewhere else.
Oh, like on the tour if somebody pukes?
Yeah.
That's a good question. That I don't know. All right, salinization. where there's too much salt left behind through evaporation or saltwater intrusion. So that works really well for Salt Lake City and all the salt fields. But it could be toxic for plant growth. Salt is a mineral. It does help, but like anything, too much of something can be toxic. This is what your lab is going to be about. You're going to find how much is too much. Wednesday.
Have you ever heard of the anything would you be fun? Basically means like the good stuff is the bad stuff.
Oh, sorry. Too much what?
Too much of the good stuff is the bad stuff.
Yeah, it's 100% true. You're welcome. All right, so a few different types of irrigation. The first one is furrow. I've seen this one pretty commonly, especially with your shorter vegetables, where you get trenches down each aisle, you fill them with water. Yeah, fill them with water. It's about 65% efficiency. Yep. The issue with this one is you get the water logging and the salinization because that water will sit, some of the water will evaporate, and then leave those salt and those minerals behind. I mean, even you can think about how full of minerals the water here in Colorado is, like how it leaves colors in your toilet or your sinks. Mm-hmm. Yes, I'm sure.
Really?
Yes. Colorado is like known for minerals in their water. It's called hard water.
The water
Well,
actually.
you drink water out of the tap, don't you? No? I don't. I'm not picky. I don't taste the difference, but my husband does, so he drinks filtered water. Which, by the way, if you watch that, what is it, the series on Netflix called Rotten that I was talking about before break, they actually have an episode. It's like 70% of water bottles that you buy at the store is just tap water.
Yeah, I don't know why people don't know this.
I know.
What? Because, yeah, you can literally test the pH level on it to prove this.
Mm-hmm. Yep. Sorry.
Like my friend, they bought a hard port filtration system tap because when they were tired of buying water bottles, so they don't use tap water.
Mm-hmm.
And the water bottles that they got, I'm like, those are tap water. My first time, I'm like, what's this? I got the pH game. Shows the exact same tap water and water bottle.
You're good? Okay. The next one is flood irrigation. Kind of the same concept. You flood the fields. There's a little bit less trenching. You're always going to have mounds where things are building up and the roots are holding on to the soil. You do get a little bit more efficiency in this. The 70-80% of that water reaches the roots. It's still easy. It's cheap. You still have the same downsides, though. You still have the water logging and the salinization. Huh? Yep. Yeah. There we go. Spray and drip. Yeah, so you have your description, your efficiency, your upside, your downside. Yep. Mm-hmm. Yeah, that was the first one we did. Mm-hmm.
Water irrigation, what they do to dry spot?
I would say yeah. I would say it would be considered flood. Because it's not thrown. Yeah, what's up, Leland?
What was the percentage for the first one?
65.
Okay, thank you.
Everyone good? Hey, you can see I copied this image. It's got a watermark on it. All right. Spray irrigation. This is probably the one everyone always thinks of. Just like sprinklers, you pump water through a hose and it comes out. 75 to 95% spray. Where you do lose it is to evaporation. Why you typically are always supposed to water in the mornings when it's cool. It will evaporate less. More efficiency, however, this is more money and uses a lot more energy. Yeah. Yeah, night too. Yeah, when everyone's done with this one, I'll go back to furrow really quick. Everyone good? There's furrow. See, now you can sound really smart on road trips when you pass the farm and you can be like, hey, look, that's furrow irrigation.
Ain't nobody paying attention to what's around the road trip.
I do.
Oh.
Chris.
Old people look like my dad's the same way.
Are you good?
And he's like,
Okay.
oh, look at the cows. And I'm like, yeah, there's a rock too.
Gosh. All right, the last one is drip irrigation. It is a slowly dripping hose. It's typically buried or laid right on top, close to the roots. It's over 95% efficiency, so insanely good as far as not losing water. It also reduces weed growth. It keeps the soil surface dry, but it keeps where the roots actually are moist, especially useful in perennials. It is, however, the most expensive, and if you plow, you would have to remove those drip lines. So it could be very tedious. Once you guys are done with this, in your packet it says rank the order of irrigation types in increasing sustainability. If you don't draw a picture, I'm okay with it. Just because you're having a lot of you to type it in. So sustainability, not efficiency, but sustainability.
Sustainability meaning sustaining plants, or how easy is it to sustain for humans?
For the environment.
Okay.
Yeah. Look at the chart that you've built. And we'll go over it, but I'd like you guys to work on it. And so sustainability, you're looking at what's most environmentally friendly and what's going to be able to keep it going. So what type of irrigation would be most efficient to least efficient? Sustainability wise, I shouldn't say efficiency, sorry. The scary things?
Yeah, all these guys. Carrots sitting on the piles of that.
right, what did you come up with for most sustainable to least sustainable?
Spray, trench, flood.
All right, drip, spray, trench, or furrow, then flood. Okay, because it's trenches. Flood, spray, furrow, drip. Okay. Any other?
Spray, flood, furrow, drip.
Spray, flood, furrow, drip. Okay.
Are we going in from most to least or least?
Yeah. So I think I said one, and I think your packet says the other. But I figure if I see one of those at either end, I know which direction you're going. In increasing sustainability. So yeah, I said it the opposite. I apologize.
Oh, I did my backwards.
Yeah. But usually I can catch on to that. So remember when we're looking at sustainability, we're talking about environmentally friendly. Your drip irrigation is going to be the most sustainable. So your highest efficiency, keeping the soil intact, things like that. So this will be your most efficient. So if you paid attention to your packet, not me, then that would be on the very right side of your packet. Yeah. Your least environmentally friendly would, depending on how you justify it, is typically going to be spray. Yes, it's very efficient, but we're losing a lot to just straight up evaporation. Probably tie between that and furrow. They've kind of both got those downsides where you get a heavy amount of salinization and waterlogging. I would accept that, yeah. Drip, flood, furrow, spray. Furrow and spray, like I said, I could switch them, justify either one of those being the least sustainable, but drip would definitely be your most economical, but that is unfortunately it's common for those things to be more expensive. All right, so quick little case study. It's going to be a short video on the Ogallala Aquifer, which I love saying Ogallala because it's fun. But yeah, kind of. My mom lived in Olalla, so it's without the ga. So this is the largest aquifer in the entire U.S. Remember, the aquifer is that below ground storage of fresh water that we tap into. It spans several states, including Colorado. We feed a lot into it because we're one of 2 out of 50 headwater states. So Hawaii and Colorado are the only states in the U.S. that don't get their water from another state. Everything comes pure here. So.
Well, I mean, Hawaii is surrounded by water, that makes sense.
The rock.
In the state of Kansas, agriculture is king. Along with high yields of corn and soybeans, Kansas is the top wheat-producing state in the U.S., with yields of more than 382 million bushels in 2012, according to the USDA. The secret to this land's bounty is not just the soil that covers it, but also something below ground that no one can see: the Ogallala Aquifer, the largest freshwater aquifer in North America.
For decades, you've had incredible production of agricultural crops on top of this, and largely that's because of the incredible water resources that have been available to it.
The Ogallala Aquifer, also known as the High Plains Aquifer, is a groundwater storage reservoir that stretches 174,000 square miles underneath parts of 8 states, from South Dakota to Texas.
This well here is 303 foot deep.
Stan Townsend, a 6th-generation farmer from Weston, Kansas, grows corn, wheat, pinto beans, and peas on his land. Like many farmers, Townsend depends on the aquifer to irrigate his crops, especially during times of extreme drought.
This country is about weather, and right now it's sure not in our favor.
Today's irrigation technology is able to pump out water that has been in the aquifer for hundreds of thousands of years in just a matter of minutes, a rate which far outpaces how fast nature can replenish it, threatening the overall sustainability of the aquifer and agriculture.
This well over on the southwest was right at a 2,000 gallon minute well, and now all we're getting out is about 600.
According to the Kansas Geological Survey, groundwater levels in the aquifer have dropped an average of 14 feet since 1996, about a foot a year. Aquifer drop rates suddenly doubled, an average of 2 feet a year between the start of 2011 and the end of 2012 alone.
Since about 2011, there's been a significant drought, and this is really across most of the High Plains aquifer. But this area, as well as others, you're now in a period of extreme to exceptional drought.
Dave Heineman, a hydrologist at Michigan State University, is leading a team of scientists funded by the National Science Foundation that is studying the aquifer. The team is analyzing data from as far back as the 1800s on changes in climate, irrigation technology, and water policy to build models that could forecast what the future holds for the aquifer and for farming.
When we feed the climate into these models, we're able to predict what happens with the water levels. And as long as we have pumping data, we really get a great understanding of the system.
One of the reasons why the aquifer replenishes or recharges so slowly is due to the water cycle itself. When precipitation in the form of rain or snow hits the ground, some of it runs off. Some evaporates back into the air from the ground, or is transpiration from plants. What doesn't run off or evaporate slowly seeps down through the soil and its layers by gravity in a process called percolation. In western Kansas, it can take 1 year to recharge the aquifer by less than an inch.
There's not enough recharge out here, not enough precipitation.
During the drought of 2012, Mitchell Ballman, a fourth-generation farmer outside of Hoxie, Kansas, was able to maintain his crop yields only by pumping more water out of the aquifer.
In 2012, we were drastically impacted. I mean, it affected our crops, definitely affected the aquifer. We depend heavily on the Ogallala, which is what we're pumping up for our pivot irrigation.
Now, in an effort to extend the life of the aquifer, Ballman and other farmers have started a grassroots effort to cut back pumping by 20% over the next 5 years.
I think we're averaging probably 2.1 foot a year is what we're dropping. That's why we're looking ahead to the future to try to promote saving, being proactive instead of reactive.
But sustaining the Ogallala aquifer and Kansas agriculture must also include more scientific research. Hyman's team is working with local and state government officials, water policy experts, and farmers to develop a long-term model for aquifer water use, based on more precise measurements of precipitation, percolation, and natural recharge, better monitoring of agricultural pumping, and forecasts of changes in climate and population.
To do anything about sort of forecasting what happens in the future, we have to work with both the farmers and the policymakers, because as we do these scenarios of the future, we have to have a pretty good idea that the scenarios we're running are feasible.
We've got to start someplace. We've got to get this thing moving. It's too important.
Improving water policy and reducing water usage are not only key to sustaining the Ogallala aquifer, but also to maintaining a way of life in western Kansas and across the entire High Plains region.
It's so you can theoretically create water, yes, but it's very energy intensive.
You just gotta fuse hydrogen and oxygen.
Yes, which is actually not as easy as it sounds. So when we're talking about the aquifer, the parts in this map that are red are the ones that are getting used up, or the parts that are getting used up faster than it's replenishing, or recharging is their official term for it. How would an aquifer recharge? Rain, exactly. Yeah, rain, anything that soaks through the ground, puts water back into that aquifer, and we're able to bring it back up. So if a guy spends the money to drill 300 feet down and a year later he's got to keep drilling another, what do you say, 2.1 feet every year. That's going to cost him more and more money to be able to pump that aquifer, and eventually he's going to hit solid clay layer, not be able to get to it. It's called impermeable. So that's why that's so important. That's something that's being completely drained in our agricultural areas where we get our corn and our soy and all of that from. They're losing their water if they don't figure out how to do it sustainably. All right. That's reverse osmosis water, and that's very expensive to do. All right, we've got like 7 minutes left of class. We've only got a couple more things to go through. Pest control methods. All right. Oh, I should have put my meme in here about ladybugs and aphids. So sad. All right, so the U.S. Uses 1/3 of the pesticides worldwide. So we use it more than just about anywhere else, or do use it more than anywhere else, but we also grow a lot more in agriculture than a lot of other places as well. So kind of makes sense. Pounds of pesticides applied to crops based on watershed. So watershed, remember, is like a big bathtub for the area. We're in the Fountain Creek watershed, so if I go out to the parking lot and tell Isaiah to dump a gallon of oil in the parking lot, that oil is going to make its way to Fountain Creek, right? So don't do that, disclaimer. So you can see heavily what river is right here. The Mississippi River. That's where a lot of the agriculture comes from. Those pesticides leach into the Mississippi River. If you remember, we have a dead zone down here, and that's part of the reason. If we're putting pesticides and killing animals and herbicides and killing weeds, and it makes it down the river, it's going to kill everything down here too. So that leads to part of the reason there's a dead zone, no plant or animal life in the Gulf of Mexico. We have a few different types. We have broad-scale pesticides, we have herbicides, which attack competing plant species, and then we have fungicides, which is, most fungus is actually good for plants, but there are a few that are very hurtful, and metals are really big on killing that. That's even for like fish tanks and stuff. They'll use metal like copper to kill things in a fish tank.
Fungi?
Yeah, fungi, sorry.
Oh, I wanted that yesterday.
We have two more types. It's the 1, 2, 3, 4, 5. I just only put 3 types on this one slide. The what? Aside. Yeah, side means to like kill. So it's not a prefix, it's a suffix. There you go. Suffix of side means it's killing something, like suicide, homicide, genocide. Yep. Connections being made. All right, number 4 and 5, rodenticides, so killing your rodents, and other insecticides. I always think of those like the roaches, stuff like that. It's not the same as insecticides you'd put on like your plants to get rid of like aphids.
Like raid.
Yeah, that's what I think of as things like raid for that one.
Raid and the one that kills wasp.
Oh yeah, that one's good.
Ironically, like black wasp build a hive on it.
That might explain why I have like 5 started ones like right inside of my front door. What? It just went funny. All right. Raid Shadow Legends. All right. Some drawbacks to pesticides. They kill non-target species. So I'm sure you guys have heard a whole lot about the bees, and the death of the bees means the death of agriculture, which means, yeah, we're all gonna die. And it also kills nitrogen fixers. So those bacteria and everything in the soil that converts unusable nitrogen into the nitrogen the plant can absorb, it kills those too.
All the ants that in the world use that too.
That wouldn't surprise me.
Why ants? It's something so small that you don't think of that everybody does all the time, but ants actually do so much for this earth.
Number 2, bioaccumulation. We talked about the DDT with the cats of Boreno. Bald eagles are a big thing for it. Whales are bigger fish. Bears are bigger mammals. So you have a tiny bit of pollution in here, like arsenic or lead, then they get eaten, those get eaten, and so on and up the food chain. They're gaining more and more toxins, which is why it's really important you know where your seafood comes from, right? Well, there's bad seafood from the U.S. too, so it's not always about import. Oh yeah, I hate it. Number 3, natural selection resistance. We get those positive feedback loops where you get eventually pesticide resistant bugs, right? Because they get left behind, they have a little higher tolerance, and they create babies that have a little more tolerance, and so on. We have already created several pesticide resistant bugs. Same insect, just can handle it better. And last negative feedback is the pollution of the groundwater. So you put that pesticide, herbicide, whatever in there, it goes into the groundwater, comes out. That's the same even with your toilet water. So everyone that flushes prescriptions down your toilet gets into the groundwater eventually, gets into the streams, the rivers. Yes, that's why they actually have very gender confused fish in Washington State that can't procreate.
Gender confused fish.
Yep.
I've heard of all.
Yep.
I've heard of all.
Because so many prescriptions are in the water. This is also your pesticide drift, same concept. It diffuses into the water, whether it's underneath or in the streams. 5. Yep. This is the last one. Toxicity to humans. So eventually it gets back to us, especially when you look at the bioaccumulation. And it can come in all sorts of different ways, and it can come in all sorts of different, or cause all sorts of different issues. Like we had with all the forest fires over summer, a lot of people were complaining of headaches. That's air pollution. Volatile organic compounds is like your gasoline, VOCs, your benzene, stuff like that. All right. That is it for this. Like I said, we'll start your lab on Wednesday. For those of you that are online, I'm going to bring you your stuff tonight. If you want me to text you before to let you know I'm on my way, just email me your phone number.
Yes.
That's not email.
222.
You already texted me.
All
All right. That is it for today. Really?
I had to get some ice in that.
Oh my gosh. That I will see y'all on Wednesday. Bye.
Bye, everybody. Yeah, Wednesday.
So she's not coming.
All right. Bye, guys. Hold on a second.
Miss P?
Must not.